Alright, this video is on another rule when it comes to division and exponents. So now this rule shows that we have a fraction, a divided by b, then the whole fraction is raised to a power, to an exponent. So what we would do here is we would say, well, a to that exponent and b to that same exponent. Now the reason this works is, let's say that we had a over b raised to the third power. Then what we have is we have that fraction three times, a over b times a over b times a over b. Well, when we do our math, a times a is a to the third, and b times b is b to the third. So this rule is for when we have a fraction that is raised to an exponent. Okay? So let's look at our first example. In our first example, we have 3/6 to the fourth power. Now you may choose to go ahead and simplify your fraction to 1/2, or you can go ahead and work with 3/6. However, you're going to still have to reduce at the end, and when you reduce at the end, you're still going to get your same answer had you gone ahead and said 1/2. So just to make the math a little easier, I'm going to go ahead and reduce this fraction. So I have 3/6, which will be 1/2 over 4. Okay, so this is now 1/4 divided by 2/4. Okay, 1 to the fourth power is 1, and 2 to the fourth power is 16. Okay, and I'm just going to go ahead and show you the other way. If you didn't reduce it, you would have 3 to the fourth over 6 to the fourth, and 3 to the fourth is 81, and 6 to the fourth is 1,296, and then to reduce that, 81 goes into 81 once, and 81 goes into 1,296 16 times. So it's just a little easier to go ahead and reduce at the beginning of your fraction. Okay, our next example is 2/5 to the -6 exponent. Okay, so this one's a little more complicated. Okay, so basically what we have is 2 to the -6 divided by 5 to the -6. Okay, I'm going to go ahead and write this horizontally so I can see a little better what I'm working with. I have 2 to the -6 divided by 5 to the -6. Okay, now this goes back to a rule from another video. When we have a base raised to a negative exponent, we have to set up to simplify to make a fraction 1 over that base to the positive exponent. Okay, so basically to simplify both of those, I have 2 to the 6 divided by 1 over 5 to the 6. Okay, now I have two fractions. I'm dividing them, so I'm going to follow my rules for multiplying fractions, in which I multiply and then flip that second fraction. So that's 5 to the 6 over 2 to the 6. Okay? Alright, so now 1 times 5 to the 6 is 5 to the 6. And, I'm sorry, that should have been 1. And 2 to the 6 times 1 is 2 to the 6. Okay? And now we're going to simplify. 5 to the 6 is 15,625. And 2 to the 6 is 64. Okay? Now because we couldn't reduce the fraction up here 2 to the 5th, we can't reduce this one. I would prefer maybe us not to change them into mixed numbers at this point. So since I had a typo, let me go over this problem one more time. We had 2/5 raised to the -6. So based on our rule, and here was our rule, when we have a fraction raised to a power, then we take the numerator and raise it to that power, and the denominator and raise it to that power. So I took the numerator and raised it to -6, and I took the denominator 5 and raised it to -6. Okay? Here, I just rewrote it horizontally so that I could see that this needed to be simplified and this needed to be simplified using our rule from a previous video. Okay? So now I've rewritten these simplified, 1 over 2 to the 6 divided by 1 over 5 to the 6. Then I used my dividing fraction rule, and that I multiply and flip that second fraction. So I have 5 to the 6th over 1 because I flipped it, and then I simply do the math. 1 times 5 to the 6th is 5 to the 6th, and 2 6 times 1 is 2 to the 6th. Then I said 5 to the 6th is 15,625, divided by 2 to the 6th is 64.